Geotrig outline lesson 48. We're going to talk about powers of trig functions. We have evaluated trig functions already, and that was just taking sine, cosine, tangent, cosecant, secant, and cotangent of angles in degrees and angles in radians. Today we're just going to kick it up a notch, and we're going to do the exact same thing. But this time, we're going to add powers on it. Now, as it says there, we have three different ways people like to write powers of trig functions. The thing about it is the fact that one of them I don't like, we would definitely probably never use, and that technically would be the first one. Sine of theta squared. To me, that means I have to square theta, and then I can take the sine of it. So we generally never, well, I don't think we ever, will square an angle. It doesn't work that way. We will more likely use the next two. And the next two are interchangeable. Sometimes it's easier to think of one using one over the other. And so what we have here is the quantity sine theta squared. We can also write that as sine squared theta. I am, and the book is, and most likely other places, they're going to default to the far right one of sine squared theta. They are going to want to use this one. Sometimes we'll start off in this form, and we'll go to the quantity squared or cubed or whatever power it ends up being for simplification. Because really what we're going to do is we will, on the bottom there, we're going to just switch the sine, cosine, tangent, and so forth function into its ratio first, and then apply the power. So we have to do what we did last time first, and then you could square it, cube it, square root it, whatever you need to do to it. That's how you evaluate functions. You do what you did before by switching to its ratio, and then you square that ratio. We have to just evaluate. Now these ones are individual. The next problem after these two, we will put it together to evaluate by adding and subtracting them as well with common denominators. But that's what we're going to have to do. Now, this is how I am going to have you guys approach your problems. I'm starting things off this way because that way there's no confusion because this one's already got a set of parentheses. I'm going to show you what the other option for writing it as right underneath it. And we could write this as sine of negative 60, because that's what it is. But then they're going to sit there and place an extra set of parentheses. See how this could get confusing versus the other way. I'll have an extra set of parentheses. I avoid that by putting the 3 on as a power on sine versus on the outside of parentheses. But really, this is what's going on. Because now, all I have to do is evaluate what's sine of negative 60. And then cube it. Now, there's a couple different options here again. You can take out your unit circle, and you can go negative 60, which will all be where? 300. Or you can add 360, right? If you add 360, find a coterminal angle, which happens to be 300. So, essentially, I am changing this to a coterminal angle between 0 and 360, because we like those angles. And it's on our unit circle, so you look there, and again, what was the sine of 300? So it's a negative square root of 3 over 2. And that fraction is to the power of 3. Guys, there's no guarantee that these are going to be nice. They might be some not so nice numbers. If it had a square root and it was squared, they would cancel, remember. So, what does it mean to have an exponent on a fraction? What can I do? What can I do with that 3? That third power? Okay. In other words, I can cube the top and cube the bottom. Notice that when it's a negative times negative is still negative. So this will be, I can bring that negative way out front if I really felt like it. Wouldn't that be the square root of 3 cubed over 2 cubed? And we all know what 2 cubed is. That's 8. So that's definitely over 8. What is the square root of 3 times the square root of 3? Square root of 27? No. That'd be square root of 3 times square root of 3 times square root of 3. But what is square root of 3 times square root of 3? 3. It's just 3 because it comes as square root of 9. Square root of 9 is 3. So wouldn't that be 3 and you still have a square root of 3? And there is your simplified answer. Cotangent squared of 330 degrees. Now, I'm doing this one because it's one of the little 3's. It's got a reciprocal function in it. But I'm keeping it between 0 and 360 so we don't have to do coterminal angles and reference angles if we don't want to. So it's 330 is nice, and I'm not going to change it. So, I don't like cotangent though. Cotangent is what? 1 over tangent. So this becomes 1 over the tangent of 330, and that whole thing will be squared. What is the tangent of 330? Again, this is not one of my, it's actually not on the unit circle directly. So, could I actually go to a reference angle on this one? Because it's a tangent. So I'd rather maybe use one of my triangles. What would the reference angle of this be? What's the angle it would take to get to the x-axis?
30.
It'd be 30 in here, right? So tangent of 330 is the same thing as tangent of 30?
Yep.
Or is it?
No. Yeah.
What's missing?
Square. Negative.
Negative. Why?
Because it's on the bottom.
Because all students take calculus. At this point, it might be easier to find the tangent of 30, and the tangent of 30, since we probably forgot, we will make our, oops, not pi. I don't know why we put pi in there. We're in degrees. 30, 60, 90. Where are the ratios?
Square root 3.
Where?
On the, like, no, on
Yeah.
the left side.
Left side.
And then 2, and then 1.
Where does 2 go?
My partner goes on, but I think it is
Boom. I always like to go 1, 2, 3. The larger number gets the square root. Where's 30? What's the tangent?
negative.
It's 1 over square root 3. When you divide by a fraction, you do what?
Multiply by the reciprocal.
So it equals a negative
Square root 3.
square root of 3. Uh-oh, I forgot something. What did I forget? I forgot to bring the square along. And so, when you square a negative, it becomes, and square root of 3 squared, it's 3. So that would simplify down just to 3. On this example, we're going to tie a couple of them together, and I changed them to Radians. Because we should be able to do this in radians as well because it happens to work the exact same way. The reason we're doing this is the fact that eventually we are going to have to solve equations. And to solve equations, you will have to take square roots sometimes or take powers, and you're going to need to know how to deal with those. This is no different than what we did separately on the two problems before. We do it separately now, but we need to keep our signs correct and then gather up like terms. Now, there's a couple things wrong with the first one. Number one, it's in negative 9 pi over 4. So it's a negative, and it's larger than 360, or 2 pi, sorry. So we probably should have to find coterminal angles, and it's cosecant, so it's actually the reciprocal of which one? Sine. So let's fix coterminal angles first. So this becomes cosecant squared of what? You can add 8 pi over 4. Why am I going to add 8 pi over 4? Because that is 2 pi. And if I add 8 pi over 4, you get negative pi over 4. Oh, that's kind of interesting. That's in the same exact spot. So when I fix this one now, the other ones are going to be fixed as well, right? That's kind of nice. Some people don't make those connections and they end up doing work more than once. Why? So I'm going to fix that because, again, I don't like negative pi over 4. So I change that by doing what? Adding another 8 pi over 4. But I'm also going to do that here, right? So it's cosecant squared of 7 pi over 4 minus tangent cubed of 7 pi over 4. Everybody get there. Now we can fix our functions if we need to. Tangent doesn't need to be fixed, but cosecant does. And we said earlier that cosecant is 1 over sine. So this is 1 over the sine squared of 7 pi over 4 minus tangent cubed of 7 pi over 4. So now we can go to a unit circle, and we know we have to evaluate sine and tangent technically at 7 pi over 4. So at 7 pi over 4, what's the sine value? So it's 1 over negative square root of 2 over 2 squared, right? Because it is sine squared. Minus, we know it's going to have to be cubed. I don't like tangent necessarily. Because tangent's not right on my unit circle. But what is pi over 4s? What is pi over 4 equivalent in degrees? It's 45. Well, wait a minute. We like tangents of 45s because tangents of 45s are always... I'd go back to our reference triangle. The tangent of 45s, and it doesn't matter what 45, is always going to be 1. Okay, let's take a look here. Draw another triangle. 1, 1, 2, square root. What's the tangent of 45? It's 1 over 1. It's 1. Now, the only thing you need to worry about is where is 7 pi over 4? More exact than just bottom. It's in the 4th quadrant. And in 4th quadrant, again, cosine is negative. So we have a negative 1 cubed. Again, we are creating this triangle right here, which we would say is 45. You go 1 over, 1 down to get the square root of 2. And if you were to do the tangent of that particular triangle, it's negative 1 divided by 1. All things that we've dealt with many times over. I'm trying to speed things up. Now, when I square a negative, going to the left side part there on the bottom, when I square that, it becomes positive. So I get 1 over the square root of 2 squared.
Oh, that's.
I'm squaring the fraction.
It's going to be
2 over
Negative.
4.
Oh.
Because I square the top and bottom. Minus, what's negative 1 cubed?
Negative 1.
Still negative 1. Which eventually will become positive. Might as well fix it. And what happens when I flip it? I can reduce that right now if I really felt like it. The 2 over 4 really becomes
4 over 2.
1/2. And 1 divided by 1/2.
It's 2. It's 2.
So it's 2 plus 1, which is
3.
3.
You could have just done 4.
Okay. Homework? Is worksheet lesson 48. Have a great day.